Hello everyone, welcome to our channel. In the following series, we introduce the notion of double integral. In our previous videos, we have discussed double integrals, the definition of double integral, how to convert double integrals to repeated integrals and how to solve them. Here we are going to define the integral of a function of three independent variables, the so-called volume integral, also known as the triple integral. Now let us see what is a triple integral. So what is triple integral and when it exists? So let f x y z be a continuous function at every point in a closed and bounded region R in R cube. So by a closed and bounded region, we know what is a closed and bounded region. We can consider any closed and bounded region in R3. Something like this maybe. So here we have considered a cube. The blue portion, the blue shaded region is a cube. So what we will do, we'll subdivide this region R, this cube R, into some smaller subregions, say R1, R2 up to Rn. We have defined or we have shown a subregion Ri with dimensions delta xi, delta yi and delta zi. So what we have to do next? So from this cube, this red cube, take a point x1, y1, z1. Okay. So consider the sum this. Summation I equals to 1 to n f of xi, yi, zi into delta xi, delta yi, delta zi. If limit n tending to infinity, summation of this one. If we take limit as n tends to infinity, summation of this one. If we take limit n tends to infinity, summation of this function. If this summation, if this limit tends to a finite value, then we say that the triple integral exists and the triple integral is denoted by this one, triple integration fxy z dx dy dz. This is the definition. Now let us see what does it mean in geometry, or geometrically can we represent this? What do you mean by this? So geometrically, triple integrals can be used to find total mass of a region, or we can use this to find the volume of a region. What is say? Say f of xi, yi, zi with the density of the region Ri, that is the density of the previous region, the density of this region, this density of this cube, say density of this cube be f of xi, yi, zi. Then since the dimension of this area, since the dimension of this region Ri are given delta xi, delta yi and delta zi, so obviously the volume delta vi will be delta xi into delta yi into delta zi, because we know that volume is equal to, volume for cube is equal to length into breadth into height. You can consider this to be a cuboid also, since it's not necessary that delta x, delta y and delta z are equal. So in general, the volume of this cuboid is delta xi into delta yi into delta zi. Now if we are now interested in finding the mass of this region, now what do you mean by mass? Mass is the product of density and volume. Mass is equal to density into volume. Now if xi, yi, zi represents the density, this f xi, yi, zi represents the density, then obviously since this delta vi is the volume, so the mass delta mi of this region Ri will be given by what? Density f of xi, yi, zi into the volume. Now this is the mass of this region Ri. Now if we wish to find the mass of this entire region, so obviously you have to integrate this one. So this triple integration, since this contains three independent variables, so integrating the function over x, y, z will get the total mass. So this triple integration can be used to find the mass of a region. Also, since delta vi is what? Delta xi into delta yi into delta zi. So if you take the total summation, that is if you integrate this with respect to xyz, you obviously will get the entire volume. So triple integrals can be used to find the total mass of a region, and it can be used to find the volume of a region. Now in the next part we'll see how to reduce a triple integral to the repeated one, like the previous case in double integrals. In double integrals also you have converted the double integrals to repeated integrals, then you have solved them. Here also what we'll do, we'll reduce this triple integrals to repeated integrals and we'll solve them. So for that you have to first see what is the existence theorem. Existence theorem means when double integrals can be converted to repeated integrals, and this is given by Fubini's theorem. Now what Fubini's theorem says. So suppose we are considering a function f(x,y,z) in a continuous region in R3. In a continuous region in R3. Suppose this is our region R xyz is equal to a less than equal to x, gx less than equal to y less than equals to hx, and uxy less than equal to z less than equal to vxy. So consider region like this. This may look somewhat like this maybe. This may look somewhat like this maybe. So this is our x-axis, this is y-axis, this is z-axis. So this is our region, this is R. Sorry, you have denoted this by E, but this is R in our context. So this is given. This is the plane x z equal to x u x y and v x y, and these are the functions given of y, gx and hx, and x is the independent variable taking the values from a to b. So you can consider this region. So this you can take this example. Now, if a function is continuous in this region, then what happens? Then by Fubini's theorem, we have that the triple integration f(x,y,z) dx, dy, dz. This triple integration f(x,y,z) dx, dy, dz can be written as repeated integrals of this type. Repeated integrals of this type. So, what is repeated integral? First, we are integrating the function with respect to z with ranges from uxy to vxy. Then the obtained function we are integrating with respect to y with ranges from gx to hx, and lastly we have to integrate the function with respect to x from ranges a to b. So this is a Fubini's theorem. We are omitting the proof in this one. We'll provide the proof in the coming videos. Now let us see how to convert a triple integral to repeated integrals by an example. So let us apply this theorem in an example. So consider this sum. So what you have, triple integration dx dy dz by x plus y plus z plus 1 whole cube. So the function here to be integrated is 1 by x plus y plus z plus 1 whole cube over the tetrahedron V bounded by the planes x equal to 0, y equal to 0, z equal to 0, and x plus y plus z is equal to 1. So this is our region. This is the region given. We have to integrate the function in this one. So let us first draw this region. Let us try to first draw this region. So first let us consider, so this is our x-axis, say. So the next y-axis, this z-axis. So x equal to 0, y equal to 0, and z equal to 0. We got the planes. Now x plus y plus z equal to 1. Obviously the intercept of x is 1. So suppose that is OA. So consider this point A. So suppose OA is 1 unit. Consider this point B. So OB is 1 unit, and consider this point C. So OC is 1 unit. The part of the plane will look somewhat like this. So this ABC is a part of the plane. So our region, the entire region or the tetrahedron V is actually the region bounded by this OABC. This is our required tetrahedron. Now let us see how to solve them. So since the given function 1 by x plus y plus z plus 1 whole cube is continuous in this given region, so this can be converted to repeated integrals. Now how to convert this? Now see, the lower limit of z in this plane, in the given plane, this XOY plane, that is z equal to 0. In XOY plane, z is equal to 0. So the lower limit of z is equal to 0. And moving forward, what is the highest value it can take? The highest value it can take is on this plane ABC. The highest value it can take will be on this plane ABC. And what is the value of z in ABC? Obviously, since x plus y plus z is equal to 1 in ABC, so z will be what? 1 minus x minus y. So the upper limit is 1 minus x minus y. Clear? So this is done with, we are done with z. We are the limits of z. We are done with the limits of z. Now we move forward to the limits of y. Now take the projection of this tetrahedron on XOY plane. Projection of X tetrahedron on XOY plane. Obviously we'll get this triangle. Obviously we'll get this triangle OAB. OAB. This will be the projection. Means what we are doing, we are putting z equal to 0. Projections means in this case we are putting z equal to 0. So if we put z equal to 0, so what we'll get? We'll get x plus y is equal to 1, and obviously we'll get this triangle OAB. Now in order to find the value of y or the limits of y, we have done of this in double integrals. What do you have to do? You have to roll the pen parallel to x-axis. Obviously the first line it will touch will be this OX line or OA line. In this one, since this is x-axis, the value of y will be 0, so y is 0 in the lower limit. And moving forward, the last part it will touch will be this line AB. And what is the equation of AB? Obviously equation of AB is x plus y is equal to 1, and from that y is equal to 1 minus x. So from this is y minus 1 minus x, this we got. And next, moving forward to the ranges of x. Now, x ranges from 0 till what is the maximum value? Till a. So the least value of x is 0 and the highest value of x is at a, where x is equal to 1 because the intercept is 1. The highest value is 1. So we are done with the ranges. I think it's clear. It's done with the ranges. Now we proceed to solve this one. So next. So till next line, what we will do? What we will integrate this function. We'll integrate this function with respect to z. So we integrated this function with respect to z. Now we'll put limit, our lower limit and upper limit 1 minus x minus y equals 0. After putting the limits, we'll get like this. After putting the limits, now we got function this one, we got the function this one. So what you have to do, you have to integrate this with respect to y. So integrating this, will get like this. So put the upper limit and the lower limit and calculate. After calculation, we'll get this thing. Now this converts to a integration of single variable. You know how to integrate this one. After integration, we get like this. Putting the upper limit and the lower limit, we will get the final value of this thing. So this is how we have converted the triple integrals to repeated integrals and used Fubini's theorem. So for this video, we are ending this video here. For any question, please comment in the comment section. Thank you.